Yeah, we are live. Good evening, Achut. We are live. So we are going to solve the previously asked questions in uh, this I can say HPCL examination. So these question solutions I already wrote. Okay, don't mind about it. I'll explain very clearly. Yeah, the first question is with help of four and off digit. The question is from electronics measurement. With help of four-and-a-half-digit voltmeter, the largest possible reading is. So first of all, we have to understand what does it mean by half digit. Half digit is the one which is going to show you either 0 or 1. It's not going to show more than that. A full digit is a digit which is going to show you from 0 to 9 any number, right? So he's saying 4.5 digit. So that half digit where it is placed, it is always at the leftmost side. In digital electronics, we call it as MSB, most significant bit position. So if you come digit 1, digit 2, digit 3, digit 4, this is half digit, right? And he is asking the largest possible reading is. What is the largest possible reading of the half digit? That is 1. Either 0 or 1. In that it is 1. Remaining are full digits. The largest possible reading is 9999, right? The answer will be option is C. That easy question. Option is C. See, those guys who are attending, you can type in the chat box your answers. Okay. First 3 questions, you'll find the answer. Okay, on the board itself. For the next onwards, you can answer. So this question, please all of you read it. This question is about the relationship between I can say rectangular coordinate system and what is the another one? Rectangular coordinate system and cylindrical coordinate system. Rectangular coordinate system and cylindrical coordinate system. See, rectangular coordinate system means x, y, z. Cylindrical coordinate system means rho, phi, and z. The relationship is x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. So this is a direct question. This is a direct question. Nothing to think about in this one. Nothing to think about this one, right? Harika, here row is missing. Just I wrote row due to typo, due to typing error. Row is missing here. That row I wrote here. This is row, not P. Generally we call it as row, or you can call it as P also. No issues, but we generally take it as row, right? Next question. Yes, this question you can answer. For a single phase semiconverter, what is a semiconverter? Semiconverter is the one which is having 2 thyristors and 2 diodes, right? Single phase semiconverter for continuous conduction. See, for continuous conduction to happen, there are some certain conditions. That is, first of all, load must be RL and that inductor must be enough to support for the conduction. Okay, otherwise continuous conduction is not going to happen. And there should be path also for the conduction. There should be path also for conduction. Here freewheeling diode is there. See, here freewheeling diode is there. Suppose I'm taking, observe here, I'm taking one sinusoidal waveform. I'm taking some sinusoidal waveform. Here I'm taking the input. Here I'm taking the input. Observe here carefully, please. This is my voltage input. Now what I do is I'll give triggering at some alpha. I'll give triggering at some alpha. Yes, that is a triggering angle. You know what does it mean by triggering angle? Now from here onwards, the conduction starts. Whenever, see, for a positive half cycle, this diode, this thyristor and this diode happily will conduct. This diode, this thyristor and this diode will happily conduct. Therefore, the output voltage is going to be same, but it will come from here. It will come from this place. But here when negative comes, these two are reverse biased, but freewheeling diode is there. Inductor will reverse its polarities, and it is going to conduct for next year going to give when this triggering for this thyristor, right? So for this alpha 0 to alpha, or this is pi plus alpha, that freewheeling diode is going to conduct for this region, that is pi plus alpha minus pi, that is equal to for alpha it is going to conduct. For alpha it is going to conduct. Harika, very good. Harika, very good. Only Harika is answering. Achut, remaining people also can answer, right? Next question, please. Which of the following types of instruments is used for the standardization of a polar type AC potentiometer? See, there are 2 types of potentiometers, AC and DC. Yes, for a DC potentiometer standardization, we are using standard cell. Okay, please do remember this one. Standard cell we are using. Then which instrument is used for the standardization of AC type instrument? Moving coil instrument? No. An electrostat? No. Dynamometer? No. Thermal we are going to use. Thermal instrument we are going to use for the standardization. Please do remember this point, please. Okay. Next question. Yeah, this is a simple question. If percentage reactance of an element is at 20%, means x percentage x is equal to 20%, then how much is x? X is equal to 0.2, right? 0.2 in per unit. And the full load current is 40 amperes. Then the short circuit current is that fellow given full load current. Then he is asking what is short circuit current. The short circuit current is equal to full load current by yes reactance, that is equal to how much? Even 40 divided by 0.2. This will be 400 by 2. In fact, this is 200 ampere. How much it is? Option is B, that is 200 amperes, right? Harika, yes, it is B. It is B. Yes, Kiran Yadav. Yes. Next question, please. A synchronous generator is rated at 40 MVA, means S is equal to 40. S is equal to 40 MVA. Okay. These are previous HPCL paper question solutions. In 2022, these questions were given in electrical paper. Okay. These are not my own questions. Please keep that in mind. Okay. And what is the voltage that fellow given? That is 10 kV at 50 hertz. Then the base impedance is asking Z base. I given you the formula in our live classes, that is Z base is equal to V base square by S base. V base square by S base. How much is V base square? 100 into 10 to the power of 6. Why? Because 10k 10 into 10 cube, 10 into 10 cube, 10 into 10 cube, 2 times 100 into 10 to the power of 6 divided by S base is 40 MVA, means 40 into 10 to the power of 6. 10 to the power of 6, 10 to the power of 6 gone, 0, 0 gone. You are left with 10 divided by 4. That is equal to 2.5 ohms. Direct question. See, no logic, no magic. 95% of the questions from technical are no logic, nothing. Just if you know the simple formula, you can directly tick for the answer, right? Very good, Harika. Next question. In DC machines, the method of achieving good commutation with help of interpoles is called as voltage commutation. This is also direct question. What is there in it? What is there in this one to think? Yes, it's voltage commutation. So there are different methods of a commutation in DC machine. What is commutation? Yes, what is commutation in DC machine and commutation methods. You might have been studied in your classes. Okay, yeah. Let's go to the next question. Which of the following material offers the largest value of dielectric constant? See, I suggest all the students who are preparing for this HPCL examination, little bit of knowledge from materials. Don't go for total material science lectures and all. Simply electric materials and magnetic materials, especially silicon, steel, and copper, aluminium, about the permeability. Having the knowledge on those things is important. The answer is silicon. Silicon is going to have largest value of dielectric constant. See here, I would say no procedure, nothing. If you know about this one, you can answer, otherwise no, right? Next question. If the flux produced by one coil does not link with other coil, suppose there are two coils in the vicinity. This is first coil and this is the second coil. This is the second coil. So this one, you are sending, you connect some voltage, some current is flowing. Because of that, some flux is coming. That flux is nowhere linking with the second one. Therefore, what is saying? Then the value of the coefficient of coupling is, it is perfectly zero. If it is not at all linking, that is perfectly zero. Yes, perfectly zero. See what the fellow says, does not link. If it links, then coefficient of coupling is going to exist, that lies in between 0 to 1, right? See, M is equal to K into under root of L1 L2. Most useful formula. Most of the times questions are given on this one. So K is the coefficient of coupling, right? If there is no flux linking between two coils, then K will be 0, right? Next question. In simple coplanar network, there are 7 branches. Number of branches is equal to 7. Number of nodes is equal to 4. Okay, junctions and nodes both are same. How many mesh currents are required for the solution of the network? Number of mesh currents is asking. See, B is equal to, sorry, M is equal to B minus N plus 1. B is number of branches, 7 minus 4 plus 1. So 3 plus 1, it is equal to 4. So the number of mesh equations required to solve. See, on this one, I took, I think, 2 to 3 lectures exclusively on network analysis. About this formula, I explained very clearly, right? very clearly. You can check with that. This is the formula, M is equal to B minus N plus 1, right? Next question. With reference to the skewing of the cage of the rotor of an induction motor, identify whether the given statements are true or false. See, what does it mean by skewing? See, instead of connecting, suppose if you take, this is the rotor of induction motor. Yes, instead of putting the slots and the rotor bars like this, see, this is a parallel, means parallel to the rotor axis you are putting. This is not skewing. This is not skewing. Then what is skewing, sir? What is skewing? With some angle we are going to put. With some angle we are going to put. See, here will be the slot. So this way we are going to maintain some angle between the slot to slot, not in parallel way. See, this is the axis of the rotor, but these rotor bars are not parallel to the, I can say, axis of the rotor. This is axis of rotor. Axis of the rotor, right? This is the axis of the rotor, but these bars are not parallel. Bars are not parallel, right? Here, the purpose of skewing is to reduce the some unwanted effect called as cogging. Okay, means your rotor is going to do some noise and vibrations. Okay, let's see the options. Due to skewing, the noise is reduced during the operation. Yes, statement 1 is correct. Second one is the locking tendency of the rotor is reduced. See, there are two effects called cogging and crawling. So those things will be eliminated with help of this, I can say, skewing of the rotor. Yes, both are correct. Next, single full converter bridge has dash SCRs. Say half converter, half controlled converter or semi converter means two thyristors. Full converter means all are thyristors. Yes, this is single phase full converter. I'm drawing without freewheeling diode. You know what is the purpose of RL load I'm putting here? You know what is the purpose of this freewheeling diode? Freewheeling diode gives continuous conduction. Okay, yes, clear. So how many thyristors are there? There are 4 thyristors. Full converter means 4 thyristors. Option is C. See, all questions are easy, direct questions. No question. See, there is no such question where you have to put your brain and think and do. I didn't find even a single question in all 3, I can say, HPCL papers. Okay, here R equivalent. See, you are standing here. That fellow is asking R equivalent from here. You go and stand there. Yes, you go and stand there. From there, if you see, these two are in series. 52 plus 28 is 80. 80 in parallel with the 80 is in parallel with 20. How much is 80 in parallel with 20? 16 divided by 10. I think it is 80 into 20 divided by 80 plus 20 is 100. 0, 0, 0, 0 gone. It is 16 ohms. That 16 in series with 25 plus 15 is how much? 40. 40 plus 16 is 56 ohms. Option is C. Option is C. See, for this one, if you give this question to any 10 plus 2 level candidate also, that fellow also will do it very easily. That much easy question it is. Okay. So I think no any other explanation required for this question from my side. If you are expecting any explanation, please type in the chat box. I will go with the explanation. Right. Next question. A single phase transformer, the ratio of transformation means K transformation ratio is given as 2. Okay, what is 2? What is transformation ratio? N2 by N1 is equal to V2 by V1 is equal to I1 by I2 is transformation ratio. What is turns ratio? Turns ratio means N1 by N2. N1 by N2. And the secondary resistance means R2 is equal to 0.24 ohms. Find the resistance of the secondary in terms of primary. What that fellow says is, if you are referring the entire secondary resistance to the primary, then what is that value is asking. If you refer entire secondary to primary, it is called as R2 dash. In our technical language, that is just representation, R2 dash. Okay, that is nothing but R2 by K square it will be. If you refer from primary to secondary, it will be R into K square. If you are referring R1 to secondary, then R1 dash will come, that R1 dash is equal to R1 into K square. Any impedance means it is going to have both the resistance and reactance. If you are referring impedance from primary to secondary, it will get into K square. If you are referring impedance from secondary to primary, it will become by K square, right? So R2 is 0.24 divided by K square is 4. This is 0.06 ohms. That's all. There is no big deal about it. Right? Option is D. Right? Option is D. Clear? Any further explanation if you want, please let me know. I'll give that. Next question. Mesh cannot be defined for the network. Yes. I told you this one also in our classes. That is, see, if it is a non-planar circuit, means if you are not in a position to draw that circuit on a 2D plane, that is called as non-planar, then for that one mesh is not defined, and you can't go with the mesh analysis, but you can go with the nodal analysis. Node is defined. With nodal analysis you can get the answer also, in fact correct answer, right? So I can say for non-planar circuits, mesh is not defined. Why? If you want the reason, you can think. Suppose there is some element in a 3D plane. So with that, many meshes are going to possible, which is wrong, right? Option is D. Next, find the current I in the given circuit. That is directly Ohm's law. I can say HPCL fellow is mad. Simple question. Yes, very simple question, right? Find the current I in the given circuit. So I is equal to 12 divided by 100 plus 400 plus 300. It is 800. Yes, 800 amperes. How much it is? 4 2s, 4 3s. Yes, it is 1.5 divided by 100. Therefore, it will be 0.015 amperes. That's all. 0.015 amperes. Option is A. Option is A. Okay, simple question. Next, determine the voltage at node A and B in the given network. Yes, this is point A, this is point B. He's asking voltage at A, he's asking voltage at B. See, this is also a very easy question. I don't know in what way you're going to do. Follow my method, you're going to get very easily. See, if you want to find voltage at any point, you start at that point and go to ground. Go to ground. In many ways, you can go to ground. I repeat, so this point is going to be useful for you a lot. See, answer is secondary for us. Answer, okay, for previous question. Okay, see, answer is secondary for us. Let's understand the method. If you want to find voltage at any point, you start at that point and go to ground. Okay, in that way you write the KVL. In that way you write the KVL. Sir, in many ways I can go to KVL. I can go to ground, but you choose that way. In that way you must get all voltages. Suppose what my point here is, observe here. See, this is 1 ampere, this is 1 ampere, yes, and this is 3 amperes. That 1 and 3 is coming, this is 4 ampere. So when 4 amperes is entering, I told you, when current enters at a node, that is plus, at a point that is plus. For resistance, current entering point is taken as plus. So this is plus, this is minus, obviously. Now 4 amperes is coming. In that 4, 3 is going like this, remaining 1 is coming like this. Therefore, this is plus minus. How much it is? 3 volts. This is 4 volts. Now, you want voltage of A. As I told you, start at A. I'll draw like this. I'll draw the same like this. This is plus minus 3 volt. In fact, that fellow given this one as 3 ohms. And he's saying this one as voltage VA, that one as voltage VA, and this is the ground. Any voltage is measured with respect to ground. Try the KVL. Minus VA plus 3 is equal to 0. Therefore, VA is equal to 3 volts. That's all done. VA is 3 volts. Then I want VB, yeah, this voltage. But across this you can't find, or you can write KVL. See, here, this way I'm taking VB. Yes, this is plus minus VB. This is write KVL this way. So minus VB plus 4 plus 3 is equal to 0. I think somewhere we committed mistake. Yes, VB, fine. Minus VB plus 4. How much is the current that is coming there? 1 ampere. Let me draw it again. Somewhere. I think it is not visible to me very clearly. Maybe just a minute. Yeah, we'll do this. This is VB, right? Okay, VB. 3, 1, 4 plus minus 4. Okay, this is 8 volts. My solution itself is wrong. Previous one is wrong. 4 amperes is flowing and the resistance is 2 ohms. 4 into 2 is 8 volts. This first one is also wrong. No, first one is not wrong. Because here I taken current correctly and voltage also correctly. Here the current is 1 ampere. First one is correct. So here this is plus, this is minus, this is VB. Yes, minus VB plus 8 plus 3. This way I am writing the closed path. I started here minus VB. In class I told you wherever you want to start you can start. Minus VB plus 8. Yes, and I am coming down like this, plus 3 is equal to 0. So VB is equal to 11 volts. So 3 comma 11 is the answer. Option is D. D for Delhi. D for Delhi. Yes, I took wrong that value. Current I taken correctly 4 amperes, but I'm unable to see this 2 ohms properly. That's why I took it as 1 ohm unknowingly. Therefore, I wrote it as 4 ohms, right? But I think all of you understood the procedure, right? Practice 2 to 3 questions of the same kind, then you will get very easily. Yes, sir. What is saying? Modified MC Murray half bridge inverter is dash commutated and dash source inverter. It is a current commutated voltage source inverter. Yes, this is option B, direct. That is also direct question. That is also direct question. You don't have to think about it much, right? Next question, please. The volume charge density is measured in terms of volume charge density, charge per volume. Volume units are meter cube. Meter cube is nothing but a cubic meter. No, meter cube or cubic meter both are same. So this is coulombs and this is meter cube. Let us see option A. Coulombs per square meter. No, coulombs per cubic meter. Yes, it is. Option B, coulombs per volt, nothing. Coulombs per meter, no. Coulombs per meter cube. Option is B. B for Bombay, right? Yes. Harsh Yadav. Harsh Yadav, or correct only your name? Harsh Vardhan, sorry. Tech Vijay. Okay, lot of people. In DC machine, the hysteresis laws are covered under the category of. People will get misunderstands here. That is, sir, hysteresis loss and eddy current loss. These are the iron losses which are going to depend on the frequency. Suppose if you go for a transformer, this hysteresis loss is equal to some Steinmetz constant, some constant eta into B max power x into F into volume V. Okay, this is the formula of hysteresis loss, and eddy current loss is K into B max square into F square into T square. This V is not voltage, please. This is volume. This T is the thickness of laminations. This is what? Thickness of laminations, right? Thickness of laminations. Clear? Now observe carefully. Not only a transformer, any machine, the hysteresis loss and eddy current loss are going to depend on frequency and Bmax, where Bmax is the maximum flux density in particular machine, and Bmax is directly proportional to voltage to F ratio, right? Now people will argue with me that, sir, in DC machine frequency is equal to 0. Your output frequency is 0, man. But inside of the DC machine, armature, the induced EMF is AC. The commutator is converting that AC generated EMF in the DC machine, in the DC generator, and it is giving the output as a DC. Inside the generated EMF is AC only. And if you are giving DC power supply to a DC motor, that will be converted from DC to AC by using the same commutator. Commutator is going to behave as inverter in case of DC motor, and it is going to behave as a rectifier in case of DC generator. That is the behavior of a commutator. It is doing both the actions. Commutator, I can say inverter and phase rectifier. Okay, right? Now, so what he is saying, iron hysteresis loss will be there. Hysteresis loss not only DC machine, any machine that comes under iron loss, right? Option is B. Next question. Which of the following statements about the DC series motor are incorrect? Incorrect. It's a variable flux machine. Yes, why? Because as current changes, DC series motor means the field winding is connected in series. Therefore, as current is changing, flux is going to change. Why current will change, sir? When load changes, obviously current is going to change, right? Next, its speed versus armature current characteristic is a straight line. This is the blunder. This is the blunder. Option B is correct. See, speed versus armature current is inversely proportional. Therefore, you are going to get rectangular hyperbola. It's not going to be speed versus armature current. Yes, it's going to be a rectangular hyperbola. Okay, so N versus Ia. So it will be like this, but it is not a straight line. Option B. Which one is not correct means option B. Its speed is inversely proportional to the load current. Yes, option C is correct. It must be never run unloaded. It must never run unloaded. This is also correct. But he's asking which one is not correct. Therefore, option B is not correct. Right? Next question, please. A conductor that connects the distribution substation. Yes, there is a distribution substation. This is substation, and this is your area. This distribution substation, to where from distribution substation it is going to come to your area transformer. Your distribution transformer it is. So this is called as a feeder. This is called as a feeder. Distribution substation. So distribution substation to your area transformer, it is called as feeder. Okay, feeder it is. Yeah. Next, a DC wire feeder, the drop per feeder conductor is 2%. Find the transmission efficiency of the feeder. See, for he is saying the two wire feeder. In one wire, see, the drop in one wire is 2%. Total drop is equal to total percentage total drop is equal to obviously 4% men. Therefore, efficiency is equal to 96%. What is there in that? See, in one wire, if the drop is 2%, two wires, it is a two wire. See, I will tell you here, this is a two wire DC transmission. If this wire is having 2 ohms, this wire is having 2 ohms, and a current of 2 amperes is flowing, 2 amperes is flowing, the total drop will be 4 volts. 2 into 2, sorry, 4 plus 4, 8 volts is the drop. Total drop of voltage, total drop is equal to 8 volts. It is not 4 volts, please. Both we have to consider. Both we have to consider. Any question? Any question here? If you have any question, please type in the chat box. Next one. Which of the following is an example of a symmetrical fault? This kind of questions also HPCL fellow is asking. See, symmetrical fault means what? If on all three phases at a time the fault is happening with same fault impedance, it is called as a symmetrical fault. Triple L is a symmetrical fault. It is an unsymmetrical. It is an unsymmetrical. It is an unsymmetrical, right? Triple L is a symmetrical fault. Yes, yes, triple L is a symmetrical fault. Okay. Next, for a series RLC, it is not G. RLC circuit, resonant circuit, two half power frequencies are 36 kilohertz and 25 kilohertz respectively. Find the resonant frequency. This formulas are given in the class, in our live network classes I given. Harika, Achut, you people can answer. Half power frequency is equal to resonant frequency, sorry. Yes, resonant frequency is equal to under root of first half power frequency into second half power frequency. Therefore, resonant frequency is equal to under root of 36 into 25. Root 36 is 6, root 25 is 5. That is equal to 30 hertz. How much that is? 30 kilohertz. In fact, it is that fellow given in kilo. Yeah, if you draw this way, you're going to get. This way, you're going to get. So this power, this frequency is half power frequency, first one. So this is half power frequency, second one. How to get these half power frequencies? Half power frequencies, you make magnitude is equal to 1 by root 2 times of its maximum magnitude, you can get. But don't do all that for HPCL examination. All that is not required. Just you remember this relationship. That's all. Right? Any question, ma? Any question further? Any question further in this one, please? Yes. Next question, please. In case of slip ring induction motor, external resistance are connected in the rotor circuit. Why external resistance is connected? To increase the starting torque. That is a provision slip ring induction motor is having, what squirrel cage induction motor is not having, and it will, in fact, will reduce the starting current also. Yeah, whenever there is resistance, obviously it is going to reduce the amount of current drawn in the start, right? Right? The rotor circuit to decrease the starting current, starting torque, to increase the starting torque, and to decrease the starting current, increase and decrease. Torque, see, R external is going to increase the starting torque and decrease the starting current. That's all. Option is B. Next, find the voltage at node B in the given circuit. This is node B. Node B. See, this question is a direct question. This question is a direct question. I told, wherever you are there, wherever he is asking to find you the voltage, you start there and go to ground. Yes, I am starting here, I'm going to ground. Yes, directly ground is available for me here. So I take like this. So those who are not having clarity can observe here. So this is B, this is point B, this is the ground, and this is my VB plus minus. He is asking to measure the voltage by taking B as a reference. That's why I taken plus here, right? KVL. So minus VB plus 12 is equal to, sorry, minus VB minus 12 it is. Yes, minus VB minus 12. Yeah, when you're going minus VB minus 12 is equal to 0. So VB is equal to minus 12 volts it is. That's all. Option is C. Option is C, right? Next question, please. With reference to the given, the phasor diagram, the current I1 is the phasor sum of. See, in the primary current is a primary component of load current I1 dash, and this no load component of current I1 dash plus I0 is the answer. Yes, see, this is I0, and this is, I can say, I1 dash. I1 dash, this is I naught. The phasor summation of these two is nothing but, this is nothing but I1. Number of turns are common, N1, N1, N1. If you leave N1, the figure itself says I1 is the combination of I1 dash and I naught, right? So option is I1 dash and I naught. Option is C. Very basic questions, very basic questions. Next question. Yeah, from where this got appeared? Okay, let's leave it. From where this got appeared, I don't know. Okay, leave that. 1 milliampere ammeter has a resistance of 100 ohms. So calculate the shunt resistance. Okay, see, 1 milliampere ammeter. There is an ammeter. Yes, there is an ammeter, and its capacity is of 1 milliampere, and it is having a resistance of 100 ohms. Okay, calculate the shunt resistance required to convert it into 1 ampere. Means he want to convert this one as 1 ampere. Means this current is 1 ampere, and this will fix it as 1 milli. The remaining must go here. This is RSH, this is voltage V. Both the cases voltage is same. So this is 1 minus 1 milli. How much is this ISH? ISH is equal to, what is ISH? Shunt current. 1 minus 1 milli. How much is 1 minus 0.001, right? Into RSH. So 1 minus 0.001 into RSH is equal to 1 milli into 100. So that is, you solve it. How much you are going to get here? 1 minus 0.001. Please tell me. Yes, yes, yes. How much is 1 minus 0.001? Come on here, do it carefully, otherwise you'll commit mistake. Yes, how much is 1 minus 0.001? I think it is 9.999. Right? So then you get this one, RSH, shunt resistance is equal to 1 milli, means 10 to the power of minus 3 into 100 by 1 minus 0.001. If you do this, you get this shunt resistance value. Right? Please tell me the answer, how much you got. Simplify this one. I'm not going to do that. Simplification you have to do from your side. If I do, I'll get in examination. In the examinations like HPCL, simplification is also very, very important. Most of the students will fail in doing simplification, right? That's why do it, please. Do it. How much you got? Yes. What happened to Harika, Vijay, Harshvardhan, right? And Kiran Yadav, Achyut. Come on. So as I'm asking answers, people are leaving the class. Answer me, please. Just I ask a very simple calculation. Okay. Bharadwaj saying option is B. Option is B. Is it? Is it? Yeah. Somebody saying option is B. I'm taking for it. If there is a change in the answer, please let me know. If there is a change in the answer, let me know. Okay. Next. Which fault is indicated by the given diagram? See, two lines are shorted and connected to ground. Line to ground fault. It is line to ground fault or double line to ground fault. Double line to ground fault. Harika is saying, okay, this is D. Harika, I was asking previous answer calculation. See, one thing I can say, this RSH must be very, very less when compared to 100 ohm. Why? Because it has to take more current. See, this is taking 1 milliampere. Remain total current must go. Current always choose short path. Therefore, 1000 is it's a nightmare. This is also nightmare. This is also nightmare. Answer is B only. Without solving, you can tell the answer, but none of you. I repeat, if you want to save your valuable time, follow my method. Knowingly, I did not solve this one because solving not required. Solving not required. See, total is 1 ampere. And this meter, ammeter, its rated current is 1 milliampere. Means if you are sending more than 1 milliampere through that will die, right? Therefore, out of 1 ampere, 1 milliampere will go through the meter. Remaining total current 1 minus 1 milli must go through this shunt, right? So shunt resistance must be very small when compared to this meter resistance. Meter resistance is 100. So this RSH must be less than 100. RSH must be less than 100. So option B is not correct. Option A is not correct. Less than 100 it should be. Either B or C. Either B or C is going to be correct. Right? Either B or C is going to be correct. You can check for that. Right? Yeah. So this is done. Next question, please. A 350-kilometer line is considered as, it's a long line, less than 80 km. In fact, voltage applied line to line is less than 20 kV and length less than 80 kilometer. That is a short line, short transmission line. And if voltage applied is more than 20 kV, yes, and less than 100 kV, and length is less than greater than 80 kilometers, but less than 160 kilometers, that is a medium transmission line. If voltage is applied greater than 100 kV and length is greater than 160 kilometers, then it is called as long transmission line, right? That is the perfect definition of this transmission line classification. Find the current Im in the given circuit. Yeah, Im, if you see, Im is going to be negative first of all. Why? Because current phi is coming here, some current will go, some current will go, but this fellow is asking in the reverse direction. So Im, current division, I am applying minus 5 into, yeah, I told you what is current division. If you want current in any element, take its opposite resistance by total resistance, 10 plus 40, this is 50, 10 times this is gone. So Im is equal to minus 1 ampere, that's all. How much it is? Minus 1 ampere. Option is B. B for Bombay. Yes, please say, don't feel that I'm doing it very fastly. So you can't find more simple questions than this in any kind of examination in all over India. Yes, I bet on it. You can't find more simple questions than this for a graduate level exam. I'm not talking about diploma level. So the job you are going for is management training in electrical, right? Management training in electrical, and that is after your graduation, not after your diploma, right? So this is very easy. Next, how many coordinate axes mutually at right angles to each other are set up in the Cartesian coordinate system? All three, x, y, z, in Cartesian coordinate system, all three are perpendicular to each other. All three are perpendicular to each other, x, y, and z, right? Next, a step-up chopper is supplied through a source of 200 volts. Yeah, source voltage is equal to 200 volts and operated at a duty cycle of alpha is equal to 50%, means 0.5. Then find the average output voltage of the chopper. It is a step-up chopper. Output voltage V0 is equal to Vs by 1 minus alpha. Therefore, 200 by 1 minus 0.5. So V0 is equal to 200 divided by 0.5. That is equal to 400 volts. The answer is 400 volts, right? Next, calculate the sensitivity of 1 milliampere ammeter. This is direct question. Sensitivity is equal to 1 by IFSD. What is IFSD? Full scale deflection current of the meter. 1 by how much it is? It is 1 milli. Therefore, it is 1000. 1 by current is nothing but ohm per volt, or this can be written as 1 kilo ohm per volt. 1 kilo ohm per volt. Option is D. D for Delhi. Right? Yes. Achyut, for which question you given as answer A? Previous question, huh? Yeah, previous question. So this one, on this formula, 2 times the question was given. And if you check all 3 papers, you can find on that formula 2 times the question was found. Okay. Next question, please. Find the current I in the given circuit. Same kind of question as that of previous, but here you have to take some series and parallel combinations. That's all. Yeah, 600 plus 150, 750. Okay, 750 in parallel with the 500 you do now, or any other way? No other way. Just we have to go for Ohm's law only. That will be easy for us. Ohm's law only. That will be easy for us. Yes. What is this total current I? The total current I is equal to simply 40 divided by 200 plus 500 in parallel with 750. Do this and tell me how much is I. I'm waiting for your answer. Yes, I'm waiting for your answer. Just I'm asking the calculation, not more than that, please. Just I'm asking about the calculation, not more than that. Answer, please. Yes. Come on, man. You people are very weak in calculations. Please try to improve. Calculation speed is very, very important in the examination. Okay. Harika given the answer directly, but I want this current value I, ma. I want this current value I. Anyone? What is this 500 in parallel with the 750? Come on, yeah. 500 into 750 by 500 plus 750, 7 plus 3, 1000. I think it is 1250. 0, 0 gone. 5 ones, 5 fives, 5 twos. Yes, 5 fives. Yeah, 5 fives. So 25, 20s it will go. Yes, how much it is? 20 into 15, 300. 300. 300 plus 200 is 500. So 40 divided by 500. 0, 0 gone. 4 by 5 into 1 by 10. How much is 4 by 5? I think 0 0.2. 0 0.02 is the correct. 80 milli. No. I don't want answer as I told you, Achyut and Harika. Just I'm asking about the current I. It is 0.02 I got this I. Now I want the current this small I. This is not, let's take this one as I1. I'm asking about the current I1. Now this I is equal to I1 0.02 into opposite resistance 500 divided by 500 plus 750. You do this. People are saying it has 80 milli. Maybe 80 milli is correct. I don't know the value. Okay, I give you the method. You solve it, you get. Next question, please. Which of the following methods of speed control cannot be used for squirrel cage induction motor? See, what is the difference between squirrel cage induction motor and slip ring? Slip ring induction motor is having some slip rings to do something with the rotor. Okay, means you can give something to rotor or you can take something from the rotor. That provision is there with help of slip rings. But squirrel cage rotor bars are shorted. Squirrel cage rotor bars are shorted, right? Stator voltage and stator frequency control, yes, it can be done. Stator voltage control can be done. Stator frequency control can be done. But slip power recovery control cannot be done. Yes. See, cannot be. Yes, this cannot be done. This cannot be done. Why? Squirrel cage induction motor, you do not have the provision to access the rotor. Right? Rotor. Next question, please. Which of the following types of instruments is used only for AC measurement? Only for AC. Which of the following instrument types of instruments is used only for AC measurements? Yeah, PMMC is used for DC. Hot wire can be used for AC as well as DC. Thermocouple for AC as well as DC, but only AC. Induction. You'll get a little confused with the question. He's asking which of the following is used only for AC. First of all, hot wire, both AC and DC. Hot wire type instrument is AC and DC. Thermocouple for both AC and DC. But PMMC only DC, but induction only AC. Right? Next question, please. The type C chopper is a combination of type C chopper is a combination of both type A and type B. That's all. Nothing more than that. Okay. See, these are the questions. Almost 50% of the paper we solved. Remaining 50% we'll be solving next time. Okay. Next time, that will be probably tomorrow. You'll get the information in your group and in the YouTube. Those who are new for this channel, I suggest you follow the channel so that you'll get a lot of information like this. And see, when I'm solving the paper, just I'm not solving the only questions, I'm covering the concepts also. If you have any queries regarding your HPCL preparation or any competitive examination related to electrical preparation, please contact me on this number. Contact me on this number, right? Yes. And I'm stopping here. If you have any queries, you can directly message me on this number.